I want to do a quick video on special products, and actually, I'm gonna have to do two videos on special products. I was never very particularly interested in perfect square trinomials, except for the fact that I like to write them as perfect square trinomials. And the reason why is, if you know how to factor properly, you're gonna get it. A perfect square trinomial looks like this: a squared plus 2ab plus b squared will equal a plus b quantity squared. Well, here's a very basic one, and if you take a look, I have x squared, so I get x, and I have 25, so I get 5 and 5, and they're both positive, and it's a positive 10, positive, and positive, so really, just equals x plus 5 quantity squared. Um, that's it. Uh, yeah, I don't really know what else to say about that. Um, so that's, you know, not exactly exciting. Here, I got 4x squared minus 2ab plus b squared. And I guess really the big thing is you should know your perfect squares. And I made a little chart, and you should also know your cubes. And I made a chart, and here's what my chart looks like. So I'm going to recognize that I'm going to probably end up having a 2x and a 3y. And here's the deal, because it's a negative, and that's positive, well, let's see what happens. We put in a negative, put in a negative. I get 4x, I get negative 6, I get negative 6, I get negative 12y, and then I get positive 9y squared, which is 2x minus 3y quantity squared. My a squared was 4x squared, so if you take the square root of that, a equals 2x. My b squared was 9y squared. You take the square root of that, you get 3y. So negative 2 times 2x is negative 4x, times 3y is negative 12xy. Alright, this one actually is really important. Actually, this is one of my topics that I believe is super important, and it comes up loads of different times. I'm going to do three examples. The difference of perfect squares works like this. Before you do anything else, I want you to try a couple things. I want you to multiply a plus 1, a minus 1. See what you get by FOILing. A plus 2, a minus 2. Tell me what you get. Just go down the line, a plus 3, and a minus 3. Tell me what you get. Here, you're going to get a squared minus 1. Here, you're going to get a squared minus 4. Here, you're going to get a squared minus 9. Well, this is the reverse. I want you to notice 1, 4, and 9 are perfect squares. And not are they just perfect squares. They're perfect squares of 1, perfect squares of 2, and perfect squares of 3. So it works like this. The big eraser. Works like this. A squared minus b squared equals a plus b times a minus b. You find the square root of a squared, you find the square root of b squared, and it's very easy. The square root of b squared is b. Square root of 16 is 4, so it's going to be b and 4. One's going to be positive, one's going to be negative. This one doesn't work because 3 is not square and 27 is not squared, but 3 is a factor of 27, and you get this, 3 times x squared minus 9. I'm going to keep my 3, and now I have the difference of perfect squares here. I get x plus 3, x minus 3. And my last one is a real doozy. Check this out. 16 is a perfect square, x to the fourth is a perfect square, and 81 is. Now I'm going to get 4x squared plus 9, 4x squared minus 9. This is no longer the difference of perfect squares, but it is a factor. This, however, is the difference of perfect squares again. So I'm going to keep my 4x squared plus 9, because like I said, I can't do anything with it. Square root of 4x squared is 2x. Square root of 9 is 3, so it's going to be 2x plus 3, 2x minus 3. So my point is, I can do the difference of perfect squares twice, and you always have to be careful, because you have something like this, b to the fourth minus 1, you get b squared plus 1, oops, b squared minus 1, but then you can keep that, and you can get b plus 1, b minus 1. That's always a tricky one. Alright, like I said, learn the difference of perfect squares. The other ones I'm not so concerned about because you'll find them accidentally if you're good at factoring.